Well, good morning, everybody. Welcome to today's webinar on DB2 User-Defined Functions, brought to you by Themis Training. My name is David Simpson. You have some contact information about me on the board there. You can reach me at the email address dsimpson@themisinc.com. You can find me on Twitter at ThemisDave or the company at Themis Training. On a slide coming right up here, you'll be able to get a place where you can download the slides from today's webinar. And you can actually do that right at the website there, themisinc.com. And if you click on webinars at the top of that page, you will have a link there very close to the top of the webinars page to download the slides from today's presentation. You can also get to it at themisinc.com/webinars. And that is a place where you will see not only a link to things from today's webinar, but also there are links to sign up for upcoming webinars, including we have an Oracle one coming up in a couple of weeks. And I think we have a couple more of them out there as well. A lot of them are DB2 related, but not all of them. We've got things on Java. We've got quite a few on Oracle. And then toward the bottom of that page, you'll be able to see replays of all the webinars that we've been doing for the last few years. So I encourage you to check that out. All of that is free content just for the asking. Each of the webinars has a link to its replay and the slides that were presented, and this one as well. This one should be right at the top of the page right now with a link to the slides. So the topic for today is DB2 User-Defined Functions. But of course, we have a quick word from our sponsor. Themis Training is an IT training company that provides training on all kinds of topics. DB2 is one of our strongest topics, but certainly not the only thing we do. As you can see there, we also have Oracle SQL Server, quite a bit on Java, .NET, Linux, Unix, pretty much anything IT related that you can think about is out there. Complete list of the curriculum is on that same website, themisinc.com. We do training both in a public scenario where you buy a seat in either a live or virtually delivered class. The virtual training is, well, we call it distance learning, I guess. It is live with a real instructor that you can ask questions of, and most of them are hands-on and all of that. Or we can come to you if you have a bunch of people that need the same thing. Let us know, and we'll be able to deliver anything at your site. So that's kind of what we do. As I mentioned earlier, the webinars link toward the bottom of the slide there, themisinc.com/webinars. You can get today's slides or view past webinars, both the replay and the slides. We've been doing about one of these a month since about middle of 2015 or early 2015. So 3+ years of content out there. Most of it is still relevant today, and all of that is free for the taking. So I encourage you to check that out, in addition to getting a copy of today's slides. I keep mentioning the slides because one of the most common emails I get after the fact is, can I have a copy of the slides? There are still people kind of entering the room here. So I'll say it one more time. You can get a copy of today's slides on the website, themisinc.com/webinars. Or if you just go to themisinc.com and click on the webinar link that is on the banner page, on the home page. Okay, so that's us. This is a little bit about me. I'm not going to read that to you, but I've been doing the DB2 thing since about 1993. For the last 11 years or so, I've been working with Themis as a trainer and consultant. One of the things I really like about that is I get to see how things are done in lots of different shops, and kind of keeps me in touch with what's going on in a variety of different places. So the topic for today is one that I've been encountering more and more lately, and that is user-defined functions. So in order to understand user-defined functions in a DB2 concept, let's first take a look at some of the functions that are built-in functions. I should mention also that whether you're a mainframe DB2 person or a DB2 LUW person, almost everything that I talk about today will apply to both platforms. The testing that I've done and the development of these UDFs has been on the ZOS platform, but with some minor changes, each of these should be able to work on across the DB2 family. Okay, so I'm taking a look here at some built-in functions, right? These are functions that IBM provides for us with the product. A lot of the ones you see here are actually going to be provided on almost any database platform, including things like Oracle and SQL Server, with some modifications usually. There's a bunch of different types of built-in functions, and you can think of a built-in function as a little piece of code, that is provided by IBM that we can invoke from within the context of an SQL statement. So the substring function is the first example there. I want to select only the first character of somebody's name, just the first letter. Substring function, last name, comma 1, comma 1. We call that one a scalar function because it returns, for every set of values you send in, you get one thing back. So you send in 100 last names into this function, you'll get 100 things back. Scalar is just a fancy word for one, right? One thing. So you send in one thing, you get back one thing. It's a one-for-one relationship, what comes in and what goes back out. Other examples there, right? Year function. You send in a date, you get back just an integer with only the year. Coalesce removes nulls, right? Some of you may know that one in the DB2 world as value. What happened there is IBM implemented it, called it value. If you go to the Oracle universe, they call it NVL. If you go to SQL Server, I think they called it if null. ANSI came along at some point and said, hey, that one's called coalesce. And so all of the platforms then implemented it as coalesce. But on DB2, you might also see it as value. They do the same thing. I used to say that I always use the value function instead of coalesce because I could spell it without looking it up. But it turns out this is more cross-platform, right? The word coalesce. So that just removes nulls, right? So I'm saying here, if I want, I would like the salary column if it's not null. Otherwise, please fill in a 0 as a literal. So you're kind of coalescing two values into one, and really what you're doing is replacing nulls. These are each examples of scalar functions. They operate, you send in a set of values, you get back one thing. We also have the concept of column or aggregate functions, and these work on an entire column full of data and return you one thing. So the sum function, right? I send in a column full of salaries, and I'm asking, please add them up, give me one number back. So I'm not sending in individual values here, I'm sending in an entire column of values. Count is another example. Really, there's 5 of these that we use with any kind of regularity: sum, min, max, average, count. There are others, but those are the 5 that you see used all the time. And they behave completely differently. Right? You send in a column, you get back one value. We also have something called table functions. And a table function, there aren't too many of these built into DB2, although we can write them as user-defined functions. Let's see. I'll try and show you an example at the end. This particular one is a function called XML table that sends in or takes in an XML document and then is returning a table with the defined columns there. So this one is going to define 6 columns on our little table that are going to be returned. And off to the right there, you see XPath expressions that are, pulling individual values out of this XML document and turning it into a table. This is actually a really powerful function. And if you do a lot of work with XML and DB2, this one comes in really handy. Can actually kind of shift your XML data into relational tables, at least your view of it. And you can actually create a view over XML data using this XML table function, which allows people to query XML data as if it were a table. So this is a really powerful function. It's a table function because it returns an entire table of data rather than either a scalar value or a summary of a column. And you notice that instead of putting this one in the select list, it's down in the from clause, because if you're going to select things from a table, that's where it would go, right? This is probably the least commonly used kind of functions. But when we get into user-defined functions, I see these things sometimes called parameterized views. You can use it kind of like a view, but it also will take in parameters, which is pretty cool. We'll maybe, if we have a little bit of time at the end, I'll show you a table function that I wrote that I find pretty useful. But again, probably least commonly used, especially on DB2 OS. They just recently sort of got those working well. So user-defined function are like these built-in functions. You know, IBM supplies you with a list of them, of the built-in ones, and you can look in the SQL reference guide for details about each one of those and what it expects and what it gives you back. But a user-defined function is, you know, well, IBM didn't give me the function that I need, right? So I'm going to write it myself. So we have the ability to extend the capability of the database engine with my own code. On DB2, stored procedures are really common. You can think about a UDF, it's like a little stored procedure. We write them in much the same way, but it's going to be invoked differently, right? Rather than calling it from a piece of code, we actually are going to embed the call inside of a SQL statement, right? So the two main kinds of these that we can do are table and scalar UDFs. We don't have column UDFs, at least not yet. And again, a high percentage of these are going to be scalar UDFs. Okay, so now at the bottom bullet there, we can implement these one of three ways, and I'm going to be focusing on the last one here today because I think that's going to be the most common. We'll say a UDF is either inline or an external or written in SQL PL. If it's inline, these are the simplest kind of UDFs, and it really just, these are the ones that are not very complex. In other words, if I just want to pile a couple of built-in functions on top of each other to yield an interesting result, maybe it includes a case statement or something like that. But it's essentially one statement that does some reformatting. Okay. When I say a UDF is external, I mean you wrote it in some other language, typically something like COBOL or PL1 or assembler. In other words, you can take a program that you wrote and implement it as a UDF. I've done this a little bit in COBOL. When I was a DBA in the real world, I had an application that wrote a bunch of these in C. And you take the program, you compile it, you have to get the linkage the way DB2 expects it, and then you run a create function statement that defines it to the DB2 catalog. If you're familiar with COBOL stored procedures or external stored procedures, this is very similar, right? Just are almost identical. Again, the main difference is how they're going to be invoked. The most popular way to do this now is with SQL PL. So SQL PL is the SQL procedure language. Right? It is the language that you use to write stored procedures that are implemented, at least in DB2 OS, as native stored procedures. It is a procedural language that is just an extension of SQL with procedural stuff. It's pretty easy to learn. If you've ever programmed in anything, SQL PL is going to make sense to you. And because these things run inside DB2 itself and not in an external address space, and this is especially important for DB2 ZOS, they are zip eligible when you call them from a zip eligible place. So if you're an LUW person, that doesn't have to mean anything to you, but if you're DB2 ZOS, that probably does mean something to you. It has to do with the cost of invoking them. And when I say cost, I don't mean actual, CPU or wall clock time. I mean, mostly dollars. How much are we paying for that CPU, right? So we're going to focus on the last one of these, the SQL PL User-Defined Function. And I'm going to give you a couple of examples of UDFs that I've written, all of these pretty recently, to do things that needed doing in a place that I've been. So here's the first one, and actually we'll see the code for this toward the end of the presentation. But I needed a UDF that adds business days to a date. So you send in a date. So we got the due date column from my project table there. And I would like to add 5 days to it. Now, this is actually, a date math is done very differently on different database platforms. On DB2, I actually really like this as compared to the other platforms in that we have what we call labeled durations, right? So I could say select due date plus 5 days. I could say select due date plus 2 years, right? You can easily add durations of time or subtract durations of time from a date, and it will yield you another date. What I'd like to do here, though, is add 5 days, but only count business days. So not not the weekends and not the holidays. And of course, holidays are going to be defined differently, for every organization. If you work for a government agency, you have a lot more of those. If you work for a retail outlet, you may only have a couple, right? So what the user-defined function will allow me to do is implement those business rules for, what do I consider a business day with code. And so I actually wrote one of these that deals with all of the major U.S. holidays, including the bank holidays and Mondays. And I'll show you that code. We'll actually step through it in a minute. But that add business days is an example of a user-defined function, and you see it invoked exactly like I would invoke one of the built-in functions. It's just if you go to your shop right now, if you go to your own DB2 system, you probably don't have that one because it's user-defined. So we are extending the capability of the database with my own code. User-defined function. So we're going to do just a quick look at coding a UDF in SQL PL. It's going to start with a create function header. At some point, you're going to say begin, and that's where the code starts. All right, so, and at the bottom, there's an end. And in between the begin and the end, you have your actual code. SQL PL, one of the most important things to kind of remember about SQL PL is that it is just an extension of SQL, right? It's not another language other than SQL. It's just got procedural stuff extending it. Right? So you can have regular SQL statements in there, like select, insert, update, delete. For a UDF, it's going to be pretty rare to do insert, update, and delete. And we can talk about that. Well, if you want to talk about that offline, shoot me an email because that's a real interesting topic. A lot of times these UDFs are invoked as part of a select statement, right? So if I say, select add business days, and then in my add business days function, I do an insert, that breaks kind of a fundamental rule of databases, that when I say select, I'm not supposed to actually be updating anything. Okay, so you can have modification statements in there, but DB2 may actually limit the context in which those can be used. We can, if anybody's interested in talking more about that, we can do it offline. So maybe it's best to just say at this point, it's pretty unusual to have insert, update, and delete statements in a user-defined function. It's very common to have select statements. Okay, so we can actually access DB2 data from within this built-in function, or I'm sorry, within this user-defined function. Comments in SQL PL, probably the most common way there is the first one. 2 dashes means the rest of this line is a comment. Or you can do the C or Java style comments. Everything between those two delimiters is comment. You can make it multi-line or part of a line or whatever you want. Every statement in SQL PL ends in a semicolon. Really, literally all of them. I should also say that the most common development platform for this is going to be IBM Data Studio, which is built on Eclipse. You don't have to write in Data Studio, but you're going to get a lot of help with things like debugging and other things if you use Data Studio. All right, so here's a sample of a header. So this is my add business days function. Right, I'm saying create function, Themis.add business days. Functions have 2-part names, just like everything in DB2. We have a schema and then the simple name. It probably makes sense if you have multiple schemas for tables that you would have a copy of your functions, of your UDFs in each of those environments, especially in like development, right? So if you have a development environment where you have, a unit testing environment and an integration test and a user acceptance test, you're probably going to need, a copy of your UDFs for each of those environments because you may be changing them as part of your release. The actual function name is up to 128 characters long, has to be unique within a schema. The arguments, right? So A_day in and A_num days on the second line there. Those are arguments, right? That's what the function expects when you call it. Have to send in 2 things, a date in this case and a small integer. Okay, you can send me a date and you can send me a small integer. Otherwise referred to as the signature of this particular function. DB2 does allow for overloading of these functions. In other words, if you're an object-oriented person, that probably happens a lot where you have the same function with the same name with different lists of arguments, and DB2 will invoke the one that has the signature that matches what you called. This thing returns a date. So you send me in a date and a small integer, and I give you back a date. Right. Deterministic is fancy words for this function returns the same thing given the same conditions. In other words, if I say take today and add 5 business days, right, September 27th plus 5 business days, it'll give you an answer. If I send you in the same arguments 5 minutes from now, it'll give you the same answer. So the input determines the output. Right? Not deterministic. If you think of the built-in functions, these are all categorized the same way. And the best example that anyone can think of a non-deterministic function is the rand function, right, which gives you a random number. Rand is like the ultimate non-deterministic function. It's going to give you something different every time, right? So this one's deterministic, and that by telling DB2 that, it affects access path selection when you start using this, especially if you put it in table expressions and things like that. All right. So the arguments can be 128 characters long too, the names of them. I usually follow a convention where the arguments start with _, the names of them, because when you get down into your code, it makes it easier if you follow some kind of naming convention to to be able to identify them. They're going to start looking like names of columns or variables that you define as well. Right. The body after the begin consists of actually up to 5 parts. We can define variables, we can declare conditions, we can have cursors, we can have handlers, and code. I'm not going to break down each of those 5 right now. Particularly the conditions and the condition handlers deal with exception handling. If you've done native SQL stored procedures, then this is familiar to you. These are the same 5 parts that you have in any SQL PL program, whether it's a stored procedure or user-defined function or whatever. You'll see in the samples that I give you, well, you'll see all of these actually. But most importantly, probably you can declare variables and cursors if you need them. They do have to be in this order. In other words, your variable declarations have to go up at the very top. Once you declare your first condition or cursor, you're done with variables. Okay, so they do have to be in this order. And if you start actually writing executable code, then you're done declaring all of the things above it. Okay. So here's a simple example. I've got a UDF called count_emps. And this is going against the good old IBM sample database that's been kicking around in DB2 since 1982, right? We've got that little employee table. If you've been working with DB2 for any amount of time, you've seen this thing, right? So this is the function says count the employees, right? That count_emps. It takes in a parameter called a_dino, it's character 3, and gives you back an integer. And you see I'm declaring a variable here, right? Declare vCount as integer. I'm initializing it to an initial value of 0, set vCount equals 0. And then I'm going out to my employee table, selecting count asterisk into vCount, that's my variable, from the employee table where depno equals a_dino. That's the argument, that's what you sent me in. And you see where using a convention that clearly identifies variables and arguments becomes pretty helpful here, because columns on tables and variables and arguments all kind of look the same in SQL PL. Okay, so I'm just doing a quick count. How many employees are in that department? And then that last statement at the bottom, return v_count, that is the integer going back. Right, so you send me a department number, I send you back an integer. Okay, this is, by the way, a deterministic function still. And you might say, well, you know, the number of employees in a given department could change, you know, tomorrow, which is true. When we say it's deterministic, though, we mean that given the same data conditions, it will always return the same thing. Okay. There's no outside influences like random things that would change it, or time of day. So, you know, a function that returns you the time of day is not deterministic, right? It'll change every time you run it. This one, given the same data conditions, it will return the same thing. Okay. So let's see an example of maybe invoking that. So here I'm doing select some things from my department table, which was a different table than what the UDF used. Give me a department number and a name, and I would also like how many people work in that department. And so I'm just invoking the count_emps function to provide me with that. Now, if you didn't have the function, there'd be a bunch of ways you could do this. You could use like a scalar full select instead of the function. You could join employee table and department table together with some kind of group by to count up the employees. But if you're going to have to do this a lot, this is kind of encapsulating that code that counts employees into that little function. Okay. So you see it counted them up for all the departments that start with D. Right? D01 is called Development Center. When I ran the count, I didn't get anybody. There's nobody that actually works in it. D11 and D21, one of them had 9, one of them had 6. So the function's just doing the counting for me. I send it a department, it gives me back the number of people. So a simple example of a UDF. All of the other things you can do in there, I mean, we've seen examples of some of them, right? You can declare variables, you can assign variables. We've got if, case, while, loop, repeat. So you've got conditional logic in the if and case. You've got looping logic, while, loop, repeat, and for are all different ways of putting a SQL PL program into a loop. The main difference is how you get out of that loop. You'll see one of them used in an example in just a moment. Get diagnostics, signal, and resignal all have to do with exception handling, which is a little bit beyond the scope of what we're going to talk about today. You can declare variables called SQL code and SQL state in the program that can be used to check for errors. But again, you really need a more complete understanding of exception handling in SQL PL. You'll see an example of it in some of the future sample code that I give you, but we're not going to talk about it in detail today. So there's the example of declaring SQL code and state and then using it. I guess we will talk about exceptions just briefly here. You can think about, there's a couple of different ways you can get exceptions in a SQL PL program. So here I've hard-coded a bad date into a regular old select statement. I've said take December 32nd of 2010 and try and cast that as a date. And if you've been around DB2 for a while, you know that that will yield you a -181 SQL code. And the way SQL PL works is it's just actually going to stop right there and throw the error back at whoever called the thing, which is probably not what you want, but that is what happens by default. You can also think of exceptions happening in maybe unexpected places. So this is just a regular set statement, right? Set variable 1 equal cast v2 as a date. Well, you see what v2 is up here, right? To 2010-12-32. So if I take that character thing and try and cast it as a date, it's not going to work. This isn't what you think of as a traditional SQL statement, but it's going to have the same problem, right? And you're going to get a -181 SQL code, right? So what you're going to actually need is exception handlers. And again, we're not going to talk about this in detail. But for those of you who maybe have a Java or object-oriented background, you can think of your entire SQL PL program as kind of a big try block. And the exception handler will be the catch, right? What do I do when I get a particular exception? You actually code a handler for this and put a little bit of code in there to handle the exception. Okay. SQL PL can be used in stored procedures, user-defined functions, and if you're on LUW, triggers. If you're on DB2 ZOS, you can use it in triggers beginning in version 12. So version 12 is out. A lot of my clients are trying to get there, but not a ton of people actually up on version 12 yet, but it is out there and available. And when you do that, you get a new use for SQL PL. Okay. All right, so the rest of the presentation is going to go through some examples. Just a couple of examples here, and really the entire code is in there. So if you actually download the slides, you can cut and paste this into your own environment, or if you would like, if you send me an email, I'll be happy to send you the source code for any of these, although it is all in the presentation. I guess one thing I should say, before you just rip off my code, which is fine, plagiarism is okay in IT, right? We steal each other's code all the time. Just make sure you, of course, test, right? So no representation is made that this code will do exactly what you expect it to in your environment. Please test for your own uses. And on some of these, you may adjust it, right? You may say, I like that add business days function, but my rules about holidays are different than yours, so you fix it, right? You make it work for you. So this is the add business days function. Takes in a date and a number of days you want to add and returns you back a date. And you see at the top there, I'm declaring a bunch of variables. This v return at the very top of the declarations is going to be ultimately what gets sent back to the caller. So we define a variable to hold it, and at the very bottom, and I'm going to scroll forward a few screens here. Bunch of screens. The very, very bottom, you look to see we're actually returning that v return back to the caller. Okay, so I'm defining a place to put it, and then I'm ultimately going to return it. And you see I've got a bunch of other variables for things that I'm going to need to keep track of as we go. I'm going to skip forward to a couple of slides here. This is actually the beginning of the code. Now we have a handler up there, which I'll talk about in just a minute. But this is where the actual code starts. So those first two things, if a number of days is null or a day in is null, those were my two arguments. Then I'm going to throw this back at you. I'm going to say one of the key things about arguments in UDFs is that they can always be null. There's no way to specify on a SQL PL UDF anyway that an argument doesn't allow nulls. Right. So it would be perfectly okay from a SQL coding perspective for them to send me a null. But what I'm saying here is this UDF doesn't accept them, right? This UDF, if you send me a null in either one of those arguments, is going to signal SQL state 75003 is an error handling statement that just says make this error happen. And it turns out SQL state has a bunch of values reserved for your use, right? So in my environment, 75003 means arguments may not be null. So that signal means make this error happen, right? Throw an exception if you're a Java person. With the message text, your arguments can't be null. Even if I get by that, I'm checking a second thing, another edit. A num days better not be too big or too small. In other words, this function can add or subtract up to 720 days. The reason for that is because every additional day that I have to check, you're going to see we're going to go into a loop and we're going to keep adding a day to the date and see whether it counts and then keep going. The more days that I have to add, the longer this function is going to run. So I've set kind of an artificial limit here. I don't want to deal with more than a 720, right? You don't tell me to add 1,000 days to your date. So 720 is about what, 2 years? So we're just setting a limit, and that's, in my case, strictly for performance. The function could take more than that, but again, the more days you ask me to add, the longer it's going to run. So if that one happens, I'm going to throw you back an error that says SQL state 75002. Your second parm has to be between minus 720 and plus 720. All right. This v increment is what I'm going to add to the date every time I want to check the next one. So I'm saying if you're subtracting dates, I'm going to move backwards. If you look up at v increment, it defaults to a +1. I'm saying if you give me a negative number, I'm going to start subtracting rather than adding. Okay. And then one last thing to check. If at the very bottom there, if number of days is 0, in other words, you told me to add or subtract 0 days, I'm done. I don't have anything to do, right? And I just set v return equal to the input. So I just give you back what you sent me. That go to exit drops you past everything to the very bottom, right? We don't do anything else. All right. Then I'm going to go into a loop. And most of the rest of this, if you keep scrolling down 2 more pages, there's an end loop way down here at the end, and everything between for these 3 slides is part of that loop. I don't know how much of this to go through in detail, but what you can see if you pick through this code is I'm adding a day. That's that first line there. V increment, remember that was either 1 or -1, depending on whether I'm moving forward or backwards. And then I'm checking to see if that day counts. All right, so what days count and what days don't if I'm adding a business day. Up here, I'm doing some basic day of week checking. I'm also taking the month and the day and sticking them into a character variable. And you can see I'm checking it down here on the third from the bottom line there. If VDay, that's really just the month and the day. So here are some days that don't count, right? Well, starting there with if VDay of week is in 1 or 7. The day of week is a function, a built-in function that I've called there that says, hey, take the date that I'm looking at and see if, give me what day of the week is it. 1 is Sunday, 7 is Saturday. Right? So if I'm Saturday or Sunday, I don't count. Iterate is a special looping verb that just says, I'm in a loop, skip this iteration, go to the next one. So basically we'll go back to the top of the loop and do the next thing. And I'm using iterate here anytime I encounter a date that doesn't count. So the first check there, if I'm Saturday or Sunday, iterate, don't count me. If I'm any one of those dates, so I actually hard-coded my fixed holidays. If I'm at January 1 or July 4th or November 11th, I think that's Veterans Day, or December 25th. So that's New Year's Day, 4th of July for us Americans, right? Veterans Day for us Americans, or Christmas Day. Those are for the shop I'm working in, those are the fixed holidays. They never count. So I'm checking the easy stuff first, right? Because the more you get down into the loop, the more complicated things are going to get. So if I'm any of those things I don't count, I just iterate. If the day of week is 2, that means a Monday. Well, we got all kinds of weird things in the US anyway that go on Mondays. You can see here, if I'm January, February, May, September, or October, then I need to go check and see about Monday holidays. In other words, those are the months that contain a Monday holiday. And the way I'm doing that, and I'm not going to go through this in detail right now, but I'm doing signal Monday holiday. And if you look up top, I have a handler for that, which is basically saying it's a way of making a call to another spot within the UDF. The signal is typically reserved for error handling, exception handling, but I'm using it here to trip another piece of code. You can think of this if you're a COBOL person like a perform. If you're a Java person or something like that, you can think of it like a method call, although it's not really that sophisticated. Just go do this chunk of code and then come back. And if the holiday is yes, when I come back from that, I iterate. In other words, I'm checking for, looks like MLK Day and President's Day and Memorial Day and Labor Day and Columbus Day, right? Those are in those months. This next section, if I'm a Monday and the day is January 2nd or January 3rd or July 5th or November 12th, these are like the days after a holiday. In other words, if July 4th was a Sunday, then I'm going to move the holiday to Monday, right? So in other words, I'm in this block of code where I'm a Monday. I already know I'm a Monday at the top there. If I'm July 5th, and it's a Monday, that means July 4th was a Sunday, and I'm going to transfer the holiday to Monday and iterate. All right, the next section is if I'm a Friday, and it's July 3rd or November 10th or Christmas Eve, then I'm going to move the Saturday holiday to Friday, just like I did with the Monday. Thanksgiving Day is always the 4th Thursday in the United States anyway, 4th Thursday of the month. So if I'm between 11/22 and 11/28, 11/22 is the earliest that Thanksgiving can be, 11/28 is the latest. If I'm between those dates and I'm a Thursday, it's Thanksgiving Day in the US. And that's it. Now I'm checking to see if my counter is greater than the number of days that I wanted to add. And if it is, I get out. Otherwise, I add 1 to it and I keep going. Okay. And then when I'm done here, I return. So let's look at an example invoking this thing. Here I said take 12/21 of 2018. So this is the Friday before Christmas Day. And I want to add 2 days to it. And I put the calendar up there, right? So The original date is day 0. The first day I went to didn't count, right? Saturday doesn't count, Sunday doesn't count. Monday is the 24th, which counts. Tuesday is Christmas Day, so it doesn't count. Wednesday is the second actual business day that I hit, and the query result returns that day after Christmas, right? Wednesday. So, you know, I go through this not to, you know, give you something that you can necessarily use on your own exactly as is, but as an example of taking a business problem that we wanted to solve inside DB2 and implementing it, right? Build a function out of it. And now anybody in their SQL can add business days to a date just by invoking this function that I wrote. Okay. This next one I wrote 2 different ways, and we're getting close to the end of our budgeted time together, so I'll just briefly give you the methodology of each of these. But this is simulating a function that Oracle has called initcap. And I've had, actually this came up last week. I was at a client site and a lady came to me wanting the initcap function, and I actually sent her one of the example codes that I'm going to go through here. Initcap in Oracle is a function that you send in a string and it capitalizes the first letter of every word. We don't have it on DB2 ZOS. Those of you on DB2 LUW, you actually do have it because they like to play nice with Oracle down there. But up on the mainframe, we don't have it. And so I wrote it. So it's a function called initcap. It takes in a string, varchar 32k, and returns you back varchar 32k. This way, I wrote it 2 different ways, and one of them is vastly superior to the other performance-wise. This is, I'll call it the bad way. What I'm actually doing here, if you kind of crawl through this code, is I'm looking at your string 1 letter at a time, and whenever I see a space, I take the next letter and I uppercase it. Otherwise, I lowercase it. So this was actually pretty easy to write with code, and you can see that going on right at the bottom of the screen here. If next cap is a yes, that meant the previous one was a space. I concatenate onto my return either the uppercase or the lowercase, depending on whether the thing right before it was a space. And I do that until I'm past the length of the string. Okay, so just a couple pages of code there, nothing real big. Initcap better, after I wrote the first one, I thought of a better way to do it, and I did some performance testing on the 2, and the second one is much better. But we actually have a locate function in SQL. It's a built-in function. And what it'll do is it'll give you the first position of the occurrence of a string within a string. So here, locate a space within my input string. What it's going to do is give you the offset, right? Where's the first occurrence of a space? And that allows you to do a couple things. Number one, I don't have to look at every character. I can skip over big chunks of characters. But it also allows you to get out early if you only have 1 word, right? So this top little chunk of code, if I got a 0 out of that locate, then I'm just going to uppercase the first character and lowercase everything else and send it back. So deal with the easy cases first, right? And in a lot of these, you know, if you're doing this with a name or something, it's going to only be 1 word. If I do locate a space, that means I have to do a little bit more work, and the rest of this program is dealing with that. So what I do is I keep looking for the next space, and then I uppercase the next thing after that. All right, without actually looking at every letter, I'm using that locate function to tell me where the spaces are without actually parsing every last character. Okay, so this is what's dealing with that. Go find the next space and then concatenate the next chunk of text onto the end. So we're still doing a loop, but it's going to iterate fewer times than the previous example. Okay. So here's an example of using it. Both functions actually return the same thing. I use the better one, initcap better. Send in the project name. In the center column in the result, you see the actual project name. In the right column, you see what my function did to it. All right, first letter of every word is capitalized, everything else is lowercase. Okay. So again, just a few examples, and this one I actually sent to a client last week because they needed this functionality. They're a mainframe DB2 shop, and the lady who asked me about it was coming from Oracle, and she's like, "This is, this is a built-in function in Oracle." Well, we don't have it in DB2, so we made it. A couple last things. Considerations for UDFs. Am I worried about performance? Yes, of course, right? We should always be worried about performance. If you think about that add business days function, this will get more expensive the more days you tell me to add, right? Because I'm going through a loop. If you tell me to add 10 days, I'm looping at least 10 times, actually more than that, right? Because every time I get to a day I'm supposed to skip, that adds an extra time that I have to loop. If you ask me to add 100 days, then I'm going to be looping 100 plus times. Right? So think about, how much work does it have to do? Accessing DB2 tables inside of there will obviously increase the cost. And also think about how many times the thing's going to be invoked. So that last thing, accessing UDFs with a column argument in the where clause becomes stage 2, non-indexable. So using them in the select list is usually okay, right? Because they're only going to run on the rows that actually come back to your result. Using them in the where clause, you're going to have to run the function on things that aren't ultimately going to make it into your result. And they're stage 2 non-indexable predicates, which means they don't perform real well. So to make a more clear distinction there, in the select list is usually fine. In the where clause could be more problematic for performance. Really, the key thing to think about there is how many times is it going to have to run. Right? If I do run a select and 100 rows come back, and I have a UDF in the select list, it's going to run 100 times, right? Once for each row that comes back. But if I have it in the where clause, it could run as many. The possibility of it running, once for every row on the table is actually very real. So you want to be careful where you put it and think about how many times it's going to have to run. Okay. I think I don't have time to show you the table UDF. If some of you are interested in that, feel free to shoot me an email, or maybe I'll come back in a little while and do a second webinar where I talk about table UDFs, particularly if you're on DB2 ZOS. Those haven't really been a real possibility for performance until pretty recently. But again, that's just a function that returns a table rather than just a scalar value. So that's a good opportunity for a follow-up webinar that we'll look at doing. If you want to email me, there you have the address. That's probably the easiest way to get in touch with me. Please do that rather than respond to the emails you were getting from Themis regarding this webinar, as that account may not be monitored. If you'd like a copy of the slides of this presentation, please go to the website, click webinars at the top, and you should see them there. And the replay for this will be out there probably in the next day or so. Hey, thanks for spending a little bit of your lunch break with me. Again, I look forward to being in touch with as many of you as I would like to, and have a great rest of your day.